Hi, I'm Tektronix and welcome to my channel. Today you're going to watch me repair and refurbish one of my trusted oscilloscopes here in my lab, which is the Hewlett Packard 54600B. So sit back, relax, and enjoy watching my video. So those of you who regularly visit my channel know that I use basically two oscilloscopes in my lab. One of my oscilloscopes is the HP 54600B, which is a digital oscilloscope, and you see running over there. Okay? And then I have a Tektronix 2445 analog oscilloscope. You see over there. Now, these oscilloscopes are being used regularly, and they're not the youngest anymore, so they are starting to show some signs of, well, wear and old age. And lately I've been using my Hewlett Packard oscilloscope the most frequently, and it is definitely showing its age. And I'll tell you what I mean by that. So when you look at the screen, yeah, I'm sure some of you will probably say, oh, you know, the screen looks perfectly usable. It's bright, you can read it and all that. And true enough, if there's not too much ambient light, I can read it okay. So it's okay for daily use, I guess. But if you look at the brightness button down here, okay, it's turned all the way to the right. Okay, so it's turned all the way clockwise, so maximum brightness. And let me tell you, even though in the image it looks okay, in reality it's really not very bright at all. In fact, right now you can see my bench top and the knobs of the Hewlett Packard are, comparatively speaking, being almost washed out of, you know, from brightness as compared to the image on the screen. Yeah, which, by the way, is, if you didn't notice already, a green phosphor screen. For future reference, I'm making this short shot of the oscilloscope, which is now running at full brightness. So the brightness is turned all the way clockwise, so to maximum, and I put my image test card right next to it, so to show you the difference in brightness between both, right? So the screen and the test card are now being lit by my bench top light, which is a really bright LED light source. And this is the image now after the repair and refurbishing of my oscilloscope. Alright, so a couple of weeks ago, actually I should return back into the past a bit further. So for over, let's say, almost 3 years now, I've been looking for parts to refurbish my Hewlett Packard 54600 oscilloscope, and but I mean for a reasonable price, obviously. And just recently, in fact a couple of weeks ago, on the internet, excuse me, I finally got a message that there was something available at reasonable price, which would allow me to refurbish my oscilloscope. At least that's what I hope. So the box you see here hopefully contains what I will need to do just that. So let's open it up and see what's inside, right? So okay, hang on, I don't know if you guys can see this, but I'm trying to give you a better angle. I think this will do. Yeah. Okay, here we go. So inside there are these foam blocks, yeah, which I guess you could call formed foam blocks, you know, which is great actually as a packaging material, although not very well, environment friendly, but fantastic in protecting something. So here we go. Okay. Wow. All right. Okay. Let's see if we can open this up a bit. Come on. All right. Here we go. There you go. Alright, so I don't know if you guys can see this, but hang on. I'm trying to get organized a bit here. So the packaging is great so far. And okay, here we go. Alright, so let me switch to handheld and then we'll continue. Alright, so a couple of weeks ago I got a search email warning me that something that I was looking for had become available on eBay, right? And lo and behold, it disappeared on the vendor's page, who was selling all sorts of oscilloscopes, and this particular oscilloscope became available, and well, as you can tell, it's you could say the sad remnants of a what I think is a Hewlett Packard 56400 oscilloscope. As far as I understand, this is the screen module, the power supply, which you see there at the back on the right, and I think even the motherboard of the oscilloscope. The whole front panel of the oscilloscope, unfortunately, was destroyed. Alright, I cleaned up the face of the CRT and you know, looking for any obvious spots, you know, burning or any other damage, and I did in fact find a little bit of damage, unfortunately. Let me show you. So right there on the screen right there, there's a tiny little break, you know, like, I mean, it's hard to see, but you see this little white dot here? Apparently something must have poked the screen, and what you see on the phosphor layer below is in fact the shadow thrown by this little spot here. Yeah, if I move the light, you see the diffraction spot moves along with the light source, you see. So yeah, unfortunately there is a tiny little bit of damage on the screen right here. Is that catastrophic? No. I mean, no. Probably that won't stop the screen from working, I hope. It does weaken the CRT somewhat. I mean, remember, the CRT is in essence a vacuum light bulb of sorts, so there are incredible atmospheric pressures pushing on the screen, right? So any damage of the glass envelope of the CRT is to be avoided, right? Because, well, it could cause potential catastrophic failure of the CRT, right? So yes, it's unfortunate the screen is slightly damaged. But like I said, is it catastrophic? No, I mean, no, it probably won't matter very much in use. Alright, before I start unmounting the monitor carriage, or I should say the monitor mount, I had a little bit of a closer look at, let's say, the left side of the main board, of the motherboard of the oscilloscope, and there are in fact a few things to notice which are rather interesting. So this right here is the actual processor, okay? It's not a Motorola processor. If I'm not wrong, this is a Signetics processor, but it is a 68,000. You can see it printed on the chip, right? There is, let me see, there, I would say the date code is 9109. So apparently the processor would be from 91, the 9th week. Okay, so next to the processor there is the monitor EEPROM. So this contains in fact the operating system, you could say, of the oscilloscope. Alright, so, and that is, I think, let me see, yeah, it's on its head, but I would say maybe a 4 megabyte EEPROM. I'm not sure, I need to look it up. However, the weird thing is that the date code is 9836. So which would make this EEPROM way much older, way much younger or more recent than the processor. I could be wrong, but okay, it's a bit peculiar. And then we have here the Dallas static RAM chip, which probably contains all the settings and all the calibrations of the oscilloscope. Alright? And then to finish it off, we have the Tektronix 50-pin connector at the back, which is normally used, I would say, for attaching a printer, but it would also possibly be used to program the oscilloscope, I guess. I've never tried to program a Hewlett Packard oscilloscope, but I think it should be possible. Since, if I'm not mistaken, the Tektronix parallel port is bidirectional. Okay, so it possibly one could reprogram the oscilloscope via that Tektronix interface. So yeah, it sports a processor which which is used in a Macintosh. So 68,000, right? And it runs on a 40 megahertz. It runs on a 40 megahertz crystal oscillator. You see. Alright, so to unmount the CRT module, basically, as far as I understand, all I need to do is to disconnect this connector here, like that. Okay, so by popping open these two levers, you can disconnect this little connector here, and then I basically, if I turn the CRT module over, I need to take out two Torx screws. There is one screw, and then the other one is beneath this ribbon, right over there, okay, where I'm pointing at. Yeah, and you need a Torx bit, okay, something like this. Okay. Okay, that's coming out. Okay, now I need to undo the other Torx screw, which is over here. Okay, there you go. Okay, and now I should be able to lift away the entire chassis from the module. Let me see. No, maybe I forgot something. Let me see. No, that's okay. Okay, hang on. Maybe I better place it like this. Okay. So now, normally the entire CRT module should slide away from the rest of the chassis, as far as I understand. Maybe. No, maybe. Okay, hang on. I need to... No, it should be... Yes, like this. Let me see. Oh dear. Yeah, that's a lot harder than you think. Maybe I need to pivot it away. Yeah, like that. There you go. Okay, alright, oops, okay, and now I need to disconnect a little wire, which I don't know if you guys can see this, but I need to disconnect this little test wire here. And oops, I can't tell right away how without unsoldering it. I need to have a look at how I should do that. But first of all, I need to put this down carefully, not breaking anything like that. And then I need to figure out how to disconnect this little wire here, which is the test signal wire for testing your probes, right? Alright, so my oscilloscope has an extension which was the HP1B interface, so it has an extra storage for making measurements, right? So, and that's why my oscilloscope is a 54600B. Okay, so if you let me show you from close up. Alright. There. Right, where is it? There. So there you go. So my oscilloscope is a 54600B model. Alright, and it has this module at the back, which is attached to the Tektronix output at the back. Okay, so, and it unhooks simply by lifting it up like this. It's a bit stiff, but there you go. So there you go. Alright. It hooks up to the Tektronix interface right here. Okay. So, and it has a side interface too. But as I said before, I've never actually programmed a Hewlett Packard oscilloscope or any other instrument from Hewlett Packard, so I wouldn't know what the pinout is, but I might have a look somewhere on the internet to find some information about it. Now, interestingly enough, there is a little switch at the back here. It's a bit dirty, but so let me show you from close up. There you go. So there is a little switch right here, which is mounted on the motherboard, and it's called calibration, unprotected and protected. Now currently the switch is on protected, which in my mind would be, to my mind that would be logical, of course, that you would protect the calibration. But you know, if I ever have enough money and time to have my oscilloscope recalibrated, I do not doubt that they would have to set the switch to unprotected and then proceed to calibrate my oscilloscope. But since I lack the necessary test instruments to do calibration for my oscilloscope, I will undoubtedly never do it myself. So there you go. That's an interesting little thing to remember, yeah. So the fact that the calibration switch should be kept on protected, right? Then I need to, this weighs quite a bit though. So there is a sticker here on the top of my oscilloscope, right? And it says in French, confirmation nulle si décollé. I bet this sticker was put onto the oscilloscope when it was calibrated sometime in the past. And what this sticker actually says, the confirmation is null and void when removed. Yeah, so I suppose the company that calibrated the oscilloscope just wanted to warn the user not to open up the oscilloscope if they didn't want to void the calibration of their oscilloscope. But since, you know, I'm fairly certain the calibration since then well, has well, sort of perished, more or less. I believe I can cut this sticker and be done with it. I don't know, should I keep it for originality's sake? Okay, I'll have a look if I can unstick it without destroying it, so without cutting it. If it's too much bother, I will simply cut it. Okay, here it is. Yeah, it only took, I would say 5 minutes, and a lot of this secret ingredient here, which is, well, actually just simple petrol. Okay, all it took was releasing one round head Phillips screw like this to release the case, you know, from the chassis. Once you, and normally there should be 2 of these, but one was missing. Okay, so I'll have to replace the missing one. Either way, when you release these screws, there are only 2 of them, you can simply slide back the entire case by placing your fingers on this BNC connector on one hand, and or your thumbs on this BNC connector and your other thumb on the Tektronix, and then by pushing and leveraging the whole case against these 2 connectors, you can, as it were, slide it off. And that's exactly what I did. So so here it is. Here is my oscilloscope, and boy is it dirty. I will have quite a bit of cleaning work to do. I bet it has never been cleaned. It has been calibrated, but undoubtedly it has never been cleaned. Alright, so I'm looking at the sticker on the inside of my oscilloscope, so on the CRT module, and it reads March 1998. Okay, so this month would make it let me think, 25 years ago. Yeah, so the module is 25 years old. Huh. Well, how about that? Yeah, it's more recent than the one I bought not too long ago, So the one I bought was from 1991, and this module is from 1998. Okay, well, you know, also the CRT on this one is a Toshiba, right? You can see it down there. So that's a Toshiba, let me see, an E905 4B31 SDHT. No clue what it is, but okay, I mean it's a 5-inch green phosphor CRT, that much I know, but I've never heard of a Toshiba E9054 B31 SDHT. Never. But who cares, right? So as long as it works, I don't really care about that. Now here is the little potentiometer I told you, with which theoretically at least you could tweak the brightness of the monitor. So that is exactly what I'm going to try. Before I do anything else to the oscilloscope, what I am going to do is have a close look at this potentiometer and see if tweaking it helps brightening the image at all or not. If it does, then I might, at least temporarily, not replace the CRT module after all and keep this one for a while longer. But like I said, I will more than likely replace the capacitors. Alright, I hooked up the oscilloscope to the mains through my Variac over there, and I'm going to try to see whether I can brighten the image of the existing monitor module using the little pot you see there. Let me show you that little white potentiometer over there. Okay, so that one on the schematic is labeled as brightness. You see the marking right next to it. Yeah, SUB Bri. So yeah, I'm going to try to see if I can turn up the brightness somewhat using that, and I can watch the image in my mirror over there and see whether well, it will have any effect turning the potentiometer. Now unfortunately, to be able to reach that pot, I had to unmount the module which is normally attached to my oscilloscope, which is this one here. Yeah, it's the HP54657A measurement storage module. Okay, so normally this module here gives the oscilloscope a bit more measurement memory, storage memory, and it also adds a few functionalities to the oscilloscope. Now I don't know how the scope is going to react without it, but I don't think it should cause any sort of problems. Except of course that some functions on the oscilloscope might not work the way I'm used to see them function, right? Anyway, let me hook up a probe to the oscilloscope and then see if we can turn it a bit brighter. Before I forget, the Torx screwdriver I used to unmount the monitor module from the donor chassis was a Torx labeled T10, just in case you are interested to know which type of torque I used. Now, okay, I mounted a little Phillips screwdriver head to my screwdriver, and I'm going to use it to turn the pot here. Okay, you see it's marked by a little red mark on top. Well, actually I should say pink mark, and I don't know in which direction to turn it, for brighter or less bright, so I guess we'll have to experiment a little. And I've never seen my oscilloscope run out of its case, so this will be two firsts for me. Anyway, here we go. So I'm pressing the on off button right here. 3, 2. Alright. Well, the fan is turning, so that's a good thing. Alright, so there is the image. Now let me turn the brightness knob on the front. There. Let me turn it about halfway. Okay, so about there. Alright, so now let's see what happens if I turn the potentiometer, the little pot here, to the left, right? Here we go. So first I turn it to the left. No, that's darker. Now let's turn it to the right. Okay. I turned it, I would say 20 degrees to the right now. I mean, from the mark on the potentiometer. Let me show you. So, okay. Here is the original mark, right here. And here's where the potentiometer is right now. Okay. So this is with the pot at the front of the oscilloscope, halfway up. And you can tell it's already quite a bit brighter, right? So let me turn the pot for the brightness right here. Let me turn that up all the way up. I wasn't halfway after all. Okay, so this is all the way down. So, okay, now I get it. So the little pot at the back allows you to set the oscilloscope to, let's say, minimum brightness, but now since I turned up the pot, it's always going to show an image. Weak, I admit. So this is more or less weak as an image. This is the pot turned all the way up, and this is bright. This is actually, yeah, this is actually quite bright. Not bad. Albeit, of course, that I can't turn the image now completely down. So when I turn the potentiometer to absolute minimum, there's still an image visible on the CRT. Okay, let me turn the oscilloscope around, and let's see what the image looks like when looked at in front. Okay. Alright, so this is the image I have now with the potentiometer all the way down to minimum. It looks quote-unquote bright in the camera, but let me tell you, when I look at it in person, it's not that bright. I mean, it's legible for sure, but it's really very weak. Oh yeah, it's barely legible in person. Now let me turn it up a notch. Yeah. Oh yeah, look at that. So this is maximum brightness. Alright. And that, I must say, is quite an improvement over what it used to be. So that's about as much as I dare to turn the potentiometer. Okay. So, like I said, it's about a turn of 20 degrees clockwise. And this is the image now after the repair and refurbishing of my oscilloscope. So you can tell the image is quite a bit clearer and brighter. Now let me switch off the backlight and show you the image without it. There you go. So you can tell there is certainly an improvement. Here's another tricky thing. If you are to release the CRT module from the chassis, you also need to release the power button first. Let me show you. So right down there is this plastic tab right here, which fits over this little plunger right here on the on-off button. Okay, so you need to very carefully lift that little hook on the right side to release it from the plunger, but you have to be really gentle, because if you aren't, you will break it off and then you're in a lot of misery. But yeah, apparently to unmount the module, the CRT module, I mean, you really need to unhook that first. So right there. Okay. I forgot to mention, you also need to disconnect the deflection coil connector over there. I had completely forgotten to mention that, but yeah, so there are in effect two connectors you need to undo from the CRT board, and that's the little PCB connector, PCB for, or the socket really, for the CRT, and then the deflection coil connector over there, and well, you could say the grounding connector right here, right? So technically three things you need to disconnect. So alright, so let me disconnect the deflection coil, and then we can start work on the PCB itself. Alright, the recapping of the CRT PCBs is ready. Unfortunately for me, the supplier with whom I had ordered a new cap, an unpolarized electrolytic cap, to replace this one, isn't on time. I haven't received the cap yet, so more than likely, unfortunately, I will have to release the CRT board again to solder in the new cap. But this old cap measures good still, so for now I'm going to use it as it is on the old CRT of my oscilloscope, and then once I've got the new cap, we'll see what I will do. So now I will remount the PCBs into the module of the CRT, so I have to slide it in there and then reconnect everything, and then technically I could test the CRT. Interesting little detail, you'll notice the connector on the PCB for the deflection coil. You see it there. It may seem as if you would be able to reconnect the connector either like this or the other way around, but actually you can't. If you take a close look at the connector, you'll notice that the first three pins are spaced closer together than the fourth pin at the bottom, right there. Alright, and there you go. The PCB is mounted back, 3 screws at the back, and the rest of the PCB just slides into little metal brackets over there. Alright, right there. And there's a similar bracket on the other side of the CRT. So there you go, all cleaned and ready to go. Fortunately for me, if I do decide to replace that capacitor at the back, it only takes 3 screws to release 3 screws to take out the whole board and then quickly replace the cap. I'm not going to refurbish the old monitor or the replacement monitor module yet. I just want to have a look whether I can repair it or not. Now you remember that there was some problem with this module, in that the height of the image was barely adjustable and was only about 1/3 of the height of the screen. Now I'm looking at the schematic of the monitor module, and apparently there is a potentiometer which goes to a chip which is called the UPC 1031. Alright, now so the first components I'm going to investigate are this little pot here, or trimmer, this resistor here, and then the electrolytic you see there, which apparently seems to be a 10 microfarad 16 volt. Alright, the schematic I have on my smartphone is unfortunately not correct. I checked the schematic you see there with the main board of the monitor, and well, for starters, the chip that we're looking for, namely the UPC, let me show you. So the UPC 1031, yeah, is not existent on this module. In fact, the chip that is on this one, I'll show you, is a UPC 1379C. Oh dear. So the schematic I have is really, well, I wouldn't say it's useless, but it's not very helpful. Alright, I did some research on the net, and I found the specifications, or the data sheet rather, of the UPC 1379, and well, this is a basic schematic they give on the data sheet for use of the UPC 1379. But what we are most interested in is that part over there. Okay, this is basically the vertical deflection part, because you see the 1379 is an analog chip, and it was built originally to build very simple monochrome monitors, right? And it takes care of all the deflection and brightness of the image of a monochrome CRT, you know, like that one over there. Okay, but basically what we are interested in is this part here, where it says V height. As we know, the height of the image was not correct, absolutely not. And I compared this part of the schematic with what is on the board, and actually, you know, a lot of it I found back here in this part here. So the chip is over here, and this part right here, and more specifically this little trimmer here, is what regulates the height of the image. And this big capacitor here, which is a 1000 microfarad, is actually that one over there, this one, 1000 microfarad. So I suspect there's either something wrong with this one or with this electrolytic here. I mean, these are the first two suspects. So I'm going to replace them and see if that changes anything to the image. If it doesn't, then we'll need to well, trace what other components in here and on the board, of course, might be causing the problem. Alright, I replaced 3 capacitors, so those two down there, marked with green on top, and then the one closest to the chip over there. Okay, so that one as well. They are respectively 1000 microfarad. Then the small one, if I'm not mistaken, is a 10 microfarad. I think it is. Yes. And then the other one closest to the chip, that one, is a 100 microfarad. Two of them measured bad. I'll show you in a minute how bad they were. So I replaced them, and I mounted the CRT module back on its original chassis with which it came. And yeah, well, let's check it out, right? So I'm going to connect the AC to the chassis, and well, we're going to have a look whether it works or not, right? Here we go. Okay, so now let me push the power button, if I can feel it. There it is. Okay, here we go. Alright, power is on. Now let's see what the monitor says. Ooh, okay. This is not too good. Okay, hang on. I'll put you on the tripod and then we'll continue checking. Alright, now you're mounted on the tripod. I can work on the module. Let's see. Can I change the image? Oh yeah! Look at that! I'm adjusting the height. Yeah. Well, oh. Well. The trimmer is not too good. Unfortunately for me, the trimmer is broken. Let's see, can I don't know which channel am I looking at. Is this channel 2 or channel 1? Let's see. Okay, it's neither channel 2 or channel 1. Okay. And how about this channel here? No. It's, in all likelihood, it's... Oh. Oops. For some reason it switched off. Alright. And this is the result after replacing that faulty trimmer. It appears the trimmer was broken. Also, the switch was behaving rather strangely, the on-off switch, and that's why we had that unscheduled switch off just before, right? So unfortunately there is no control panel with this chassis, so I can't really check anything, except of course the well, the monitor itself, and that's what counts, right? So the image is near perfect. Yeah, I mean there is still some slight burn-in I can notice, but yeah, I mean I don't think I can get it much better than this. Yeah, I think this is probably as good as it gets. Okay, I'm sure some of you would like to know what was bad on the replacement CRT module that I bought for my oscilloscope. And so like I said, I studied the typical schematic built around the UPC 1397 chip, so which is an analog chip really, and I discovered that at least two electrolytics were critical to a correct vertical height of the image, right? And one of those was this 1000 microfarad electrolytic. I checked it and it checks out reasonably good. Let's show you. So this is what the 1000, the original 1000 tests like. Okay, so I don't know if you can see this, but so it tests like a 950 microfarad, and it's a little bit lossy, but it's only 0.28 ohms ESR, so which is really rather okay, rather good. Okay, so basically this one, even though its value is a bit low, is okay. Right, so then we move on to the 10 microfarad, which I discovered in the vertical circuit, which is this one here. Alright, so this is a 10 microfarad 16 volts, okay, rated at 85 degrees C. So this is what it measures like. So the 10 microfarad capacitor. Okay. Here you go. Okay, so it measures as 4.3 microfarad, and look at the other numbers. Yeah, 28% lossy and 150 ohms ESR. Okay, 150 ohms ESR. Okay, so basically, yeah, the capacitor has become a resistor, right? So yeah, I needed to replace that one, and this one was located right next to the 1000 microfarad. Okay, and then I replaced the 100 microfarad, and that one measures as, I'll show you. That one measures at almost 85 microfarad. Rather lossy, I would say. Well, 2.8% loss. That's leaky. That's really leaky. And an ESR of 1.4 ohm. Not really bad, but not too good. Normally, you know, electrolytics of that kind, you know, 100 microfarad, should be below 1 ohm ESR. So yeah, basically of those three that I replaced, the smaller ones were really bad. Yeah, the big one, the 1000, was more okay, but the 10 and the 100 microfarad, no, not good. Also, when I tried to adjust the height, or the vertical height, the image kept jumping around. And I checked the original trimmer, which is this one here, and it measures out at 500 ohms. Okay, but as you can tell, one of the three legs is broken off, and that is why the image kept jumping around. Okay, so the leg was just gone. Yeah, actually I found part of the leg back on the print board. So here, that tiny itty bitty little piece of metal right here is what remains of that missing leg. Yeah. So yeah, I replaced the trimmer, and now the module works perfectly. Alright, I repaired the replacement monitor or CRT module for the HP, and you can see the components that I replaced. You know, the caps colored green at their top are the ones I replaced, and then that little white trimmer down there is the one that I replaced for the original broken one that was located there. Alright, I unmounted the power supply from the chassis to give it a final once over before I close up everything again in the cabinet, right? So yeah, so this is the power supply, and you can release it from the chassis by unscrewing just one Torx screw, which is located right here underneath the fan, you know. So if you unscrew the Torx screw completely, you can slide the board forward and then lift it out gently. There are only a few connections to release, of course, so the connection to the main PCB of the oscilloscope, so this, possibly maybe the connection to the fan, which is this one right here, okay, and then the earthing, which is this wire right here. Once you've disconnected those three wires, it's just a matter of sliding the power module forward and lifting it out and up. Okay, now I need to mount back the CRT module. And it's not so easy as it looks, but there are two hooks here, right here, and those hooks hook into the slots at the bottom of the CRT module, right? One is here, the other is over there. Okay, so yeah, I need to hook those slots into the CRT module, and I have to be careful not to break off the potentiometer right here. So I need to, you see this piece right here? Yeah, you need to pass it underneath the potentiometer. Okay, so like this, and then you need to hook the two hooks into the module, so something like this. It's not easy to do, but and you need to take your time while doing it, because if you don't, you might cause a lot more damage. Okay, here we go. So now I need to lift up the cable here. Alright, like that. Don't know, can you guys see this? Yeah, I think you can. So now I need to slowly, carefully move back the monitor module down. And I have to make sure that I'm not breaking the on-off switch you see here, right? So that piece right there, right here, yeah, needs to go underneath the power switch, and you have to be really careful when you put it back, because it's quite easy to break stuff if you're careless. Okay, I don't know why it always seems to fight a little when I want to put it back. It's as if something is resisting. Okay, let me unhook this and have a look. What is going on here? Let me see. It's as if, you know, okay. Yeah, it's seriously resisting being put back somehow, and I don't know why. I wish I knew what was resisting so much, but there you go. Okay, it's passed to the power supply, so I think we're good. Alright, so here's the front panel. I cleaned it as good as I could, as well as I could. It's not perfectly clean, but it's okay. Yeah. I mean, technically I should have released all these buttons here, to be able to clean them from the inside. But it's such an intricate little mechanism, and it's full of springs and such, that I didn't want to take the risk to do anything to it. So I cleaned it as well as I could on the inside as well. Okay, there are quite a number of potentiometers and rotary switches on the inside, and there's one long ribbon cable that we need to connect to the main board, right? So let me show you where it needs to be connected. Okay. So on the main board there is this connector right here. I don't know if you guys can see it, right here. Okay. Right there. Now that connector needs to be connected to this flat cable here. Okay. And that goes to the front like this. So it's a bit complicated to get it to fit precisely, but so first of all you connect the cable, the flat cable, to the connector right here, down here, and you can only connect it in one way, yeah, so you can't be wrong. There you go. Okay, so that's one, and then you need to clamp the cable underneath this little clamp here. Okay, there's a plastic clamp which allows you to slide the cable into place like this. There you go, like that. Okay, so now what you need to do is now we need to mount the front panel to the front of the oscilloscope like this. This slides over this. It's a bit involved. Yeah, you need to take your time to do this, because if you're going to force things you might break stuff. Okay, so you really need to take your time to figure out exactly where the front panel needs to go, and not force anything, because if you're going to do that you're going to break stuff. Alright, it took me quite a bit of wrestling, I would say 20 minutes to wrestle the whole front panel back into place, but there it is, mounted the way HP wanted it to be mounted. But oh boy, if you don't want to break anything, you really need to be careful while doing this, because a mistake is quickly made. Yeah, and you can quickly break something if you use too much force or you're too impatient. If you use either, or if you are too impatient or you use too much force, you're going to ruin things. Yeah. So my advice is, do this when you're feeling calm and composed, because it'll test your patience and your nerves. Well, the Hewlett Packard 54600B, my second oscilloscope, you could say, got a new lease of life. It's all cleaned up. The monitor module, or the CRT module, has been refurbished with brand new capacitors. Everything on the inside and the outside has been cleaned, and I hope it'll get another 10 years of useful life. And I have a replacement CRT module should I still need to replace the original one. I hope you enjoyed watching me refurbishing and repairing this oscilloscope, and I'll see you soon for another video on my channel. Thanks for watching.